Okay, so the base system is starting up. And remember, we are booted off the stick directly. So now it's basically doing some initial keyring exchanges and stuff like that. And it should be up in like 30 seconds or so. Alright, so we booted up successfully. And I am using a German keyboard, so you can see that my Y and C letters and some other letters are mixed up. So the first step for me would be to load the German keyboard layout. And now I have the letters I need. So after that's done, I can basically type in my commands, and the next step would be to partition my hard disk, or in my case, my hard disks. You can see right now there are 3 disks listed: SDA, SDB, and SDC. So SDC is the stick I'm booting off. SDA is a 150 gigabyte hard disk, and we have dev SDB, which is a 22.4 gigabyte SSD. So when installing a Linux, you need at least 2 partition, which is the root partition and the swap partition. If you compare it to Windows, the root partition is basically your C drive, and the swap partition is similar to the page file. So in this system, we right now have 4 gigabytes of RAM. So if all our programs would be using up the 4 gigabytes, the data would have to be saved somewhere, and that is the disk, and it's going to use the swap file. So that's something you usually don't want. You don't want your computer to swap, because the memory can read and write way faster than the disks. So in this setup, I'm going to set up the root partition on the SSD and also the swap partition on the SSD. And I'm going to be using the remaining space, the 150 gigabytes, to become my home folder. So if I ever want to reinstall my operating system in the future, all I would have to change is my root partition. I can reuse the swap I previously set up, and I can keep all the data I want on my hard disk. And it also allows easy setup if you have all your data on a separated disk. Okay, so let's get started by creating the needed partition. And there are basically 2 ways you could do it. You can use a GPT partition and use UEFI. That's important if you want to do some encryption, but this is beyond the scope of this tutorial, so we are going to go with a MS-DOS partition table. So first off, we are going to configure the SSD. So I'm going to use a fdisk dev SDB. And I'm firstly going to print, and you can see there are 2 partitions on the disk, and I'm going to delete both of them. And now there are no more partitions. So now we can recreate the partitions we want. So first I'm going to create a new partition, which is going to be a primary partition with a partition number 1. And the first sector will be basically the default, so after 2048 bits. And as a last sector, I'm going to type in plus 20G. So that means that we are going to create a partition 20 gigabytes in size. And then we can create another new partition, also primary, with a partition number 2. First sector default, and also the last sector default, which is basically going to use up the remaining space. So we are going to end up with like 2.4 gigabytes. It basically picked Linux as a type for both, but the second one we want to use as a swap. So I'm going to type T, partition number 2. And now I can type L to view all the possible options. And we right now need option number 82, which is Linux Swap Solaris. And we are going to press enter. And then we are going to print out our current setup again. And since it's all the way we want it, so we have a 20 gigabyte and a 2.4 gigabyte partition, we can use the write command to change to save the changes to the disks. Now that I've created my first partitions, I can also format my second one. So I do a cfdisk def sda. Hold on, I'm going to use fdisk again for this one. And we are simply going to delete the second partition. So as you can see, there is also another partition which is a Windows partition. I sometimes need a Windows, so I'm going to keep that over there. And now we are going to create a new partition, primary number 2. And again, we are simply going to use the default values, so we are going to simply use all the remaining space. And we now use another write to save those changes as well. So now we've created the partitions, and the next step would be to create a file system on the partitions. I'm going to use ext4 as a partition, as a file system, and I'm going to use the -l to give it a name. So this is going to become my root partition. And now it's basically writing the file system to the disks. So I've written sdb1, and now I'm also going to write a file system, hold on, mkfsxt4, and I'm going to do that on def sda number 2. And again, I'm going to label it, and I'm going to label this one phome, because that is going to become my home partition. And again, we simply let it write the file system. So we've now partitioned both the disks we want to keep data, and now we also have to create a file system on the swap. To do that, we simply do a mkswap. Of course, after that command has finished. So let's create the swap, mkswap. Again, I'm going to give it a name, and it will be on def sdb number 2. Okay, so since we now have our file systems, we can start mounting them. So mounting is like assigning a drive letter in Windows. Like in Windows, if you create a new disk, you first partition it, you then put a file system on it, and then you give it a drive letter, you could say C, D, E, F. So now we are going to mount the root partition to the MNT folder. Then we go inside the MNT folder, and here we are going to create a directory for the home folder. And then we are going to mount the home folder. And our home folder is, hold on, def sda2 is going to become the home folder. And also we have to mount in our swap partition, and we simply do that by using the swap on p_swap. Okay, so basically we now have all the disks where we can write the data to, but we need to get the data, and that's usually from the internet. So the next step would be to establish a network connection. So the easiest way would be to simply plug in a cable and wait for the DHCP server to give it an IP address. You could also use DHCP, CDF0, or whatever interface we have. So if we do a IP addr, you can see all the names of the interfaces. We have NP9S0, which is my Ethernet one, and we have WLP3S0, which is my Wi-Fi one. And for the sake of this tutorial, I'm going to use the Wi-Fi one. So I will be typing Wi-Fi menu, and it will also scan for wireless networks here. And I will be using the first one, the WPA2 one, and then you simply enter the password. That's now going to take a few seconds, like 5 or 10 seconds, and then it should have connected. And we can test if the connection has succeeded by pinging 8888. And now we see if DNS resolution also works by pinging a DNS, so that also works. And now we can prepare the installation of the base system. So we copy over the mirror list. Let's take a look inside that mirror list first. So the mirror list is basically a list of HTTP servers, and it also contains the location where the server is and like a score, how fast the servers are and stuff like that. So basically on all those links there is a copy of all the programs you can install using Linux Arch. So our packet manager, in our case Pacman, is basically connecting to those servers and downloading the last version of the software from those servers. We don't want to use Chinese or American servers if we are in Europe, so we are going to adjust that list a little bit. So first off, I'm going to create a backup of the mirror list. And now I could start editing the mirror list by uncommenting all the servers I don't want, or I can use some bash magic. So we are grabbing the file, and we are using SED to change to delete some lines. And we are going to pipe the output to the original mirror list. So if we now take a look at the original mirror list, it is empty. So I've made some mistake or some typo over here. Let me check that real quick. Minus E minus A1. Oh, there is a grep, which should have been an SED command. So that was a good example why it's useful to create a backup file first. And now if we take a look at the file, you can see it's just the German servers that are left. And we don't have any but the German servers. So that is going to speed up the whole installation process for us quite a bit. And now we can start installing the base system by using pacstrap. So what I want to install as a base packet is base and base devil. So this is basically the software, and those are all the libraries we need to install or use those software. Then, since I'm using an Intel, I'm also going to install the Intel U code. And since I want to use VPA or Wi-Fi later on, I'm going to install the VPA supplicant package. I think that is needed if you want to connect to hidden networks. And I'm also going to install the dialog package, which is basically needed later on to use the Wi-Fi menu after we finish the installation. So I'm going to let that run, and that is basically connecting to all the servers, or to some of the servers inside the mirror list. And now it's starting to download all the needed software. I think that's around, you can see it here, 149 different packets. So first step is to download the packets, next step is to verify, and third step is to install the packets. So that's going to take a few minutes. See you soon. Okay, so now we basically copied over all the data. You can see if we type AALS, that's the common Linux folder structure, you know, or maybe don't know yet. Okay, so the next way would be to create a so-called fstep file, which is a file system table. And that is going to define which of the partitions we are going to use. So if we do a gen step, gen fstep minus p slash mnt, then it's going to look inside the mnt folder and see what we have mounted there. So we have basically 3 files mounted there: the home, the root, and the swap. And right now you can see that it's using def-sdb1, def-sda2, and def-sdb2. So it's going to use the drive names, which is not something you want. For example, if my USB stick was recognized as def-sda, I do the installation and afterwards I unplug the stick, then all the numbers for the disks are going to change because it's always going to start with def-sda. What we can do to avoid that is by using the -L. And that is going to use the labels instead. So we have label parc, phome, and pswap. And that is basically what we want. So we can save that to the etc fstep file inside our mount directory. So, and now that we've installed it on a SSD, we are going to do one more modification where we go to the here to the root partition. And basically a SSD is not built to be rewritten as often as hard disks, so those switches are going to increase the lifetime of the SSD. So I would recommend you doing that. And we also go down to the swap partition. And also add no A time and discard over here. So now that we basically have all the stuff we need, we can switch over to the newly created partitions. So right now we are booting off the stick, and we can use the arc chroot. So basically we are changing the root from which we are running, and we are changing that to the mnt folder. So right now we are in our new Linux arc. And now we can basically start configuring the system. So instead of Windows, we don't actually have to restart. We can just jump over to the other location. So the first step we are going to do is we define a host name. And I like to use 0x00f as a host name, because when I connect to Wi-Fi networks where I shouldn't be, it usually shows up as some kind of weird error and people think that something is wrong instead of just being another computer. So etc hostname, and then we also have to save the locals we want to use. So before I use the load keys to basically load my keyboard layout, and that will not remain after the reboot, so we have to save that. Hold on, I need to pipe that into local.conf. And you can see right now I used one of those arrows. That means overwrite the existing file. For the next command, I'm going to use two of those. That means append it to the currently existing one. And then the last one will be the language variable. And we are also going to append that to the config. So now if we look inside the config, you can see we have all the 3 lines we need. And that should be the definition of the language variables. And now we also have to define the key map and the font type. So we can do that inside the vconsole.config, console.conf. And in here we simply type in key map equals DE Latin 1, font equals Lat9v16. So if you have an English keyboard, just take a look at the documentation for the English language or whatever you need. So now we also have to define the time zone. We do that by, let's list the folder first, share zone info. And in here, based on what continent, what country you're from, you can basically select your time zone. So I'm from Europe and I'm from Berlin. So this is my time zone file, and I simply need to soft link that to the etc local time file, local time. So if I do a list on the etc local time, you can see it's like a shortcut which basically leads to the original config of Berlin. So now we need to make sure that we can ping localhost and that we can also ping a localhost local domain. So both those are working, so our host file is basically correct. If that's not correct, you can edit it in here and change the values for the addresses. So I have 2 lines, one for IP version 6 and one for IP version 4. Then the next step would be to test if we can resolve IP addresses, DNS, and we can do that. If you have problems there or want to change that, you can go to the resolve.conf, and I personally prefer to use the name server 8888 and name server 8844. That is basically Google's DNS, and I prefer to use them because they update way faster than most of the other ISPs DNS servers. So after that's done, we need to generate our locals. And to do that, we first have to define which ones we want to generate. So we scroll down to DE, A, B, C, D, E. And since I'm German, I'm going to use DE underscore DE, and I want the UTF-8 one, I want the ISO one, and I want the Euro one. So now I press Ctrl and X to save, and I can confirm that with a Y. And now we can basically generate those local files. And you can see it only generated the 3 ones I uncommented. So again, if you are on some English languages, just pick the right one and generate those. So what I usually also do at this step is to edit my pacman, so my packet manager. And here inside the config there is a section called multilib. So right now we are running a 64-bit operating system, and there are applications that are only working on 32-bit. By enabling the multilib, we can use 32 and 46-bit packages. For example, if you want to install TeamViewer, that is going to work way smoother by using the 32-bit installation files. And we add another line, which is, hold on, pack mirror list. Package required and trusted only. Okay, so now that that is done, we can run a pacman update. So it's basically installing any file and answering with a yes. So now you can see it connected to multilib and downloaded a little file which is containing what programs are there. So now we basically have all the configs configured, we have all the applications we need. Now we simply need to build the Linux kernel. And that sounds way more complicated than it is. It's just a simple command. And that is all you need to do. And that is basically generating our 2 initram fs files. So when you start your computer, first you launch the BIOS, then the BIOS looks on which disk to start, then it looks on the disk, it finds the master boot record, which is basically our bootloader, and based on the bootloader it's going to load a certain kernel, and that is what we just generated. So after that's done, we also need to set a password so we can be so we are able to log in later on. Okay, and as I explained, we also need to install a bootloader because the BIOS is going to load a bootloader, and the bootloader then is going to load the kernel. And as this example, we are going to install grub. And grub is the most commonly used bootloader, the second one being Lilo. So, and we can use grub to generate a config and write it to the boot disk. And of course we are going to take a little peek at that file to give a rough understanding later on. So if we scroll down inside that file, you can see here it's starting our choices. So we have one menu entry, which is the Arch Linux, which is our default operating system we are going to start from. You can see that here they are not using the dev SDA, but they are using the so-called bulk IDs. It's pretty similar to using a label, but you can, let me exit out of here and type bulk ID. So you can see how it works. Every disk that is inside my computer has one of those bulk IDs, which is a unique identifier. That's basically the same principle as before. We don't want so if we for example add some sticks or change our hard disk, we don't want to change the order of the devices. So we are using those unique IDs instead. And down here you can see there is the first menu entry, which is Arch Linux, and there is a second menu which itself is a submenu with 2 submenus, you could say. So here is Arch Linux with Linux, and here is Arch Linux with a fallback initram fs. And you are going to see how that is going to look like after the next reboot. So now that we basically generated the file, we now have to tell the computer on which of the hard disks to install it to. So the BIOS for me is set to boot of the SSD. So that is my dev SDB. So now I do a grub -install dev SDB. And that is basically writing the master boot record onto the beginning of the SDB file. And you can see there are no errors reported, so everything went smooth as planned. And that will allow our BIOS to basically start up the bootloader, and that is looking inside the grub config file and seeing from which disk to start and which of the kernels we generated to use. So now we pretty much have all the basic stuff installed, and we could attempt a reboot. But if I just type reboot, you will get an error because we are still in our change root. So we type exit. Now we are back on the stick, and now we can simply reboot our operating system.